Welcome to this video in the Rates 2 topic on half-lives. So we want to try and understand what a half-life is, and we want to know how to determine half-lives from a concentration time plot. So we're very much in the realm of continuous monitoring of rates of reaction. Let's see how we go. So a half-life, if we see a reactant, its concentration is decreasing over time. Now, half-life is a term that's usually borrowed, very commonly used in the field of radioactive decay, but it's quite a general term for describing the loss of something or even the gain of a product as simply the time elapsed for the concentration of a reactant to halve. It's usually used for decay processes, really. So let's just have a think about what that would actually look like on this particular graph. So at time 0, the concentration is 1. So we're looking for the time it takes for that to go down to a half. So we go across to here. So it needs to go down to 0.5. How long did that take? Well, if we go down to here, we can see it's around about 14, in this case seconds. So the half-life, at least starting at the beginning of the reaction, is 14 seconds. Now it's important to realise that we don't have to start at time 0. The half-life can be defined from any starting concentration. So let's say we wanted to start off at, say, 10 seconds instead. Then the concentration at 10 seconds, if we go up to here, is going to be around about 0.6. And we're going to look for when it becomes 0.3, which would be halving. So we're going to go down to here. And here it turns out we're around about 24 seconds. So this half-life here, between these 2 points, is also 14 seconds. So we go up to 24 seconds there. So that would be a half-life. And remember, the first half-life we determined, in this case 14 to 0, was also 14 seconds. Now that's not a general property, it happens to be in this case, and we'll see more in the next video as to how you can use the trend in half-lives over time to determine the order of reaction.